Hello, everyone. So we're going to start. Hi. Welcome to Symposium number 4 of this conference, which is entitled Epistemic Uncertainty, Implicit Encoding and Information Seeking from Infancy to Preschool. So my name is Marina Bazhydai, and I'll be chairing this symposium. It will consist of 3 talks by Moritz, myself, and Tony, and then Paul Harris will be our discussant. We'll have time for a few questions after each talk, and then a bit more time for questions at the end of the symposium. And before I give it over to Moritz, I just wanted to say a few words about why this symposium came together and what we mean by epistemic uncertainty, just to put us all on the same page. So we know from a lot of literature, including work presented in the past few days, that from infancy, children are very sensitive to the kind of information that they obtain about the world, and often they encounter themselves in this state of not knowing, of this epistemic uncertainty, which takes many forms. It may take a form of a violation of expectation scenario, such as physical violations of expectations. We heard from Lisa Feigenson a lot on that, but also social violation of expectations, such as getting false information from previously reliable informant, for example. Epistemic uncertainty also comes not necessarily in violation of expectation, but also in general informational uncertainty. So that could take a form of, for example, hearing a counterintuitive testimony, or not getting any testimony and just being in a state of lack of information and a lack of sources to get this information or timely information. And finally, being asked questions that one just cannot answer. So in this symposium, we will focus on trying to underlie the cognitive mechanisms behind experience of epistemic uncertainty in early childhood, and that will range from, the implicit, and I know we don't like the word implicit anymore, so non-voluntary encoding of uncertainty, and Moritz will speak a lot about that, but also the development of communicative overt behavioral cues in response to uncertainty, which are available to young infants and preschoolers as well as they develop their communicative repertoire, which becomes much more complex. So that's our goal for today, and without further ado, Moritz from Free University in Berlin will give the first talk.
All right, thank you very much, Marina, for putting together this symposium, and also many thanks to the organizers. It has really been an excellent workshop and conference. So my talk is going to be on the processing of unexpected events in the infant brain. And first of all, I want to motivate briefly why I think it is such an interesting phenomenon to look at how infants encode unexpected events. So young infants have to make sense of their environment. They have to understand which causes the action cause in the environment. They have to understand when they move, which proprioceptive experiences are associated with those movements, but they also have to understand the physical entities in their environment, and so even more difficult social agents. So it gets even more exciting if we look at the brain of young infants, and there we find that really the first years, and in particular the first year, is a period of intense brain maturation. A lot of new synapses grow, even more perish in the course of pruning, and the connections get stronger and stronger. So from a theoretical neuroscience point of view, it has been asked if there are some general principles that guide infants' early learning processes. And here, one theoretical perspective that has captured a lot of attention in the last years has been the predictive processing account. The basic idea of that account is very similar to what I've just told you about early infant learning, that you have to make sense, even also as an adult, which effect your actions cause in the environment, how your movements change your proprioceptive experiences, and also how agents behave. And it has to be said that this theoretical account has recently applied to some domains of social cognition as well. Of course, having a theory of mind helps you very much to understand where an agent will search for a chocolate, but this predictive processing account has also been used as an explanatory framework for autism spectrum disorder, for example. So what we did in a recent perspective paper, we asked, okay, if this is a general account for how the brain works, so forming predictions about own movements and the environment, then can we explain with that theoretic frameworks the phenomena that we have in the infant literature about early infant learning? And it has to be said that the predictive processing account is a statistical learning account, so infants acquire the statistics and form Bayesian models about their environment. And here, from a predictive processing point of view, the critical question is, okay, what do the statistical models actually model? And the answer would be, okay, what the infant brain does is to try to optimize predictions in the environment. And this fits nicely to the research that is done on infant statistical learning. Namely, what is done there is it is looked if infants understand transitional probabilities between certain sounds. So if a series of sounds is shown, it is then observed if infants understand that after A and B, what follows is C, and this is, of course, a predictive process. Similarly, we can apply a predictive processing framework to many phenomena we have about we know about infants' motor learning and proprioception. Namely, if infants have the chance to move immobilely with their foot movements, what you observe is that their kicking rate increases, and when the connection is disconnected, the kicking rate even further increases. And you may interpret this from a predictive processing point of view as a prediction error. So infants try to reproduce that effect. And we also know from Somerville's work that if you give infants the opportunity to improve their predictions by giving them mitignitins, what will improve is not only their own capability to interact with the environment, but also their predictions about others' goal-directed actions. I think this whole idea gets even more apparent when we look at the way we actually test infants' understanding about physical and social events in their environment. Namely, we use violation of expectation paradigms. So an implicit assumption in these paradigms is basically that infants form and have predictions about their environment, and we then test, okay, will there be increased processing or with this wording, prediction error, when an infant encounters a physically unexpected event or an unexpected action. And we know from the nice works from Amy Stahl and Lisa Feigenson presented on Wednesday that it is that infants indeed take those unexpected events as an opportunity to explore and understand more about their environment. They test, okay, what does the ball do? What is different about this ball than about other balls when it falls through a table? So what we did in the two studies I'm presenting here, we basically flip the coin around, and we do not use violation of expectation paradigms to understand what infants understand about their environment, but we use unexpected events to understand how the infant is processing those unexpected events, and so to say, which brain activity do prediction errors elicit. So what we do is we show unexpected events in a series of domains of core knowledge, namely a person putting a brezel to the ear, a ball that goes through a wall instead of stopping in front of a wall, and two objects that move together but then are not connected, or the number of objects that change behind an occluder. So in the first step, we looked at the classical component in the ERP, and what we found here was that we had an ERP, namely at central electrodes between 400 and 600 milliseconds, we found a decrease in brain activity. However, interestingly, this was even higher for expected compared to unexpected events. Our prediction was the other way around, but there is also some literature going into the same direction. However, with ERPs, the problem is that you do not really get at the neural oscillatory dynamics. So when the brain processes information, we know that this information processing is rhythmic. And if you average the signal and the rhythm is not tightly locked to the stimulus onset, you leave that signal. You miss that signal. So what we did in the next step, we looked at the neural oscillatory activity within each trial to see which are the rhythmic dynamics in the processing of unexpected events in the infant brain. What we find here, when we really look at all electrodes at the same time, is that when an unexpected event appears, or an expected as well, we have an increase in activity somewhere between 2 and 6 hertz. And this increase is especially higher for unexpected than for expected events at 4 hertz. This gets even more obvious if we average the power over time and look at the frequency response. Then we see that, okay, for expected events, we have a clear 6 hertz response. For unexpected events, we have 4 and 6 hertz. And what really remains when we take the difference is the 4 hertz rhythm. And this fits quite neatly within the adult, children, and infant literature, that the theta rhythm is a marker of learning processes. So where is this activity most pronounced? When we look at the topography, this effect is strongest in parietal regions. And what is nice about this activity, it's really a continuous activity for the whole time of the presentation of the unexpected event. So now we are not looking anymore at a few milliseconds, oops, something happening, but we have really a prolonged difference in the theta rhythm. And what is nice about the theta rhythm, we have a better theoretical understanding what it actually does. Pushing that one step further, we now wanted to experimentally manipulate the neural oscillatory processes in the infant brain. And you can do this by a rhythmic visual stimulation. So basically what you can do is you can present a stimulus flickering at a certain frequency. And we used 4 hertz and 6 hertz. And when we designed this study, the idea was that with 4 hertz, we really target the 4 hertz theta rhythm, and with 6 hertz, we may tackle the alpha rhythm of the infant brain, and there we didn't have the expectation that we find a difference. So showing these flickering stimuli indeed entrains the infant brain, so we could experimentally establish a neural oscillation at either 4 hertz for the theta stimulation or at 6 hertz for the alpha stimulation. And now the critical question is, if we experimentally establish a rhythm at 4 hertz and at 6 hertz, would really selectively the 4 hertz respond to unexpected events, and the alpha response would not expect to unexpected events. And this is exactly what we found, namely that for the entrained 4 hertz rhythm, there was a sharp increase in activity for the unexpected outcome compared to the expected outcome, but we did not find such a difference for the alpha stimulation. All right, so what to conclude? We found across 2 studies that infants encode unexpected events at the 4 hertz theta rhythm, and we have, I presented evidence from first the ongoing activity in the infant brain, and second, from an experimental manipulation of neural oscillations in the infant brain. I have embedded this in a broader predictive processing perspective that the theta rhythm may actually be the underlying mechanism of forming and refining predictions, and that the theta rhythm is a computational mechanism for learning is very well established in adults and quite well established also for children and infants. And in one theoretical paper, we argue that it may also be a computational mechanism underlying predictive coding. The basic idea stems from the original studies from O'Keefe and Risi I hope I pronounced these names correctly. And they have discovered the theta rhythm in the rat hippocampus. And what they discovered in particular is that in the hippocampus of the rat, you have specific cells that respond to locations in a labyrinth. And as the rat proceeds through the labyrinth, these cells selectively fire for these positions, the so-called play cells. Many of you may be familiar with it. But what is really interesting about it, first, is that the activity of these play cells is active much earlier before the rat approaches this position. So it's in some sense predictive, and it really pops up again and again in the theta rhythm. So somehow the theta rhythm may help you to, predict what's coming next, and also within this prediction, integrate new information in the brain. And this seems to be a phylogenetically preserved rhythm that we not only observe in rats and in adults, but we have shown here that already the infant brain may process unexpected events and learn about unexpected events at the theta rhythm. I'm at the end. I want to thank the co-authors who worked with me on these papers, the funding sources, the parents, and the infants. And thank you very much for your attention. Thank you.
Before we go into questions, I forgot to mention that our monitors are displayed differently because our third speaker today wasn't able to travel, so she will be presenting via Skype, so I apologize for the displays for people in the back. But now let's turn the floor to questions.
I'm so glad that you mentioned the hippocampus towards the end of your talk because, oh, sorry, okay, closer. I'm so glad you mentioned the hippocampus towards the end of your talk because it's been this sort of overarching issue for me in terms of neural processing that hippocampal development is extremely protracted, yet we can find the type of predictive processing and learning that's supported by the hippocampus later in development, extremely early in development. So I guess if you're enmeshed in this literature, I was wondering about your thoughts as to why something that is hippocampally supported in adults is present in infants if their hippocampal development is, at some points just, according to some people, almost non-existent in terms of a true underlying structure.
Obviously, from the present data, we can't tell. So we know a lot about the rat hippocampus and the hippocampus in grown-ups. So I think what the theta rhythm really does is like squeezing real-time events on a shorter time scale. So to form new memories, you have to activate events that happen temporarily disjunct at the same time to really form a new connection between those. And we know quite well that this is what's happening in the hippocampus in the, and what the theta rhythm facilitates. But of course, we cannot say from the data that we have here that it's a hippocampal process or what the hippocampus is doing. So, and why I'm telling this is because, it's a computational mechanism in the brain, basically, to not only to put events close together to be able to form memories, but also if you imagine it in terms of predictive processing, you have to integrate information and be faster than real time, right? So you need a temporal compression as well to predict, what's coming up. You have to be faster than real time to know, what will it feel like to grasp? What will this person do next? And it may be, so what this computational mechanism does in the infant brain, I have no clue. If the hippocampus is involved, I don't know. I would be excited to discover, but I don't know. Yeah. So it could be a mechanism in the infant brain that helps, that facilitates these processes, but we don't have any ability to localize it in the hippocampus. So this is really a theoretical consideration which brings us to the idea, it may be really involved in predictive processing, the theta rhythm. Yeah.
Okay, next question over here.
Thanks for your talk. It was really nice to see the actual stimuli. So I was wondering, those are quite different types of events, right, that cause the the surprise, or how you would call it. And I was wondering whether you looked at different types of events also, because it wasn't completely obvious to me, your hypothesis that theta, you would find a theta effect, but not an alpha effect. For example, for unexpected actions, it wouldn't be so clear, like alpha could also play a role, no?
Sure. So I simplified it a bit in my talk, but the original prediction is also online as predicted for the psych science study. Our original prediction was that the algorithm shows a higher suppression as well, but this is not what we found in the stimulation study, and also not in the study where we looked at the ongoing activity. So yes, it was our hypothesis as well that the algorithm may play a role, but this is not what the data tells us. Yeah. Yeah, okay, sure. Yeah, because we show so many events, when we really just focus on the events within one domain, the analysis for the psych science paper really collapsed, because many infants dropped out. We had only 20 infants, 2 trials, and then the picture looks pretty fuzzy. So because we show these very different events, and our purpose, that's why I said, okay, we take these events to see what's happening in the brain, right? So I wouldn't say these are the right studies to really dissociate between domains anymore, because there our data is not strong enough. Yeah.
Last question, Barbara.
Hi. Very, very interesting. I have just one question about what you said function of theta is, so you link it to learning and prediction at the same time, and you find the increase in theta in response to the unexpected events, and I was having a little bit hard time. So I can imagine that there is learning there, because you're setting up a new representation that triggered by these unexpected outcome, but how is prediction in there?
So, okay. The question is, when does the brain have to learn, right? And this is basically when you do not have an existing, can you all hear me? So this is basically when you do not have an existing model, right? Your implicit processes can take you everywhere. You just go out of the door and you say, okay, I go to work, and that just goes. But as soon as there is a construction site, you have to work on that and update your model and integrate new information, and then find the best way to get around this construction site. So the idea is that, okay, learning is really important when your predictions or your model doesn't fit, right? This is when you need to integrate new information. And so I think these processes are inherently linked. So having an event that is not predicted requires you to learn something new. And the brain, of course, would like to know best what is happening around it, so it tries to improve those predictions all the time and integrate new information as good as possible. Did this answer your question? Okay. Thank you.
Thank you. Thank you, Moritz. I'm going to switch gears now and speak about the development of precursory behavioral and communicative cues in response to epistemic uncertainty. As you can see from my title, I'm specifically linking social referencing behavior as one such behavioral response. And really briefly, I'm focusing here on the social domain of information seeking. So obviously infants are curious beings, and they try to obtain as much information as they can from all different sources, not only through independent discovery, but also turning to those more knowledgeable others. And specifically in situations when they are not certain about information that they need, they may use cues, communicative cues that are developmentally available to them to pose these requests, so to speak, interrogative requests. And the development of interrogative communication before children are able to pose questions verbally has been proposed to manifest itself in behaviors such as pointing, babbling, and social referencing. Interrogative pointing has received the bulk of attention in the experimental investigation. Most of the people who did that are, I think, in the room. We do know that infants as young as 12 months at least would point more towards the more knowledgeable informant as opposed to a less knowledgeable or the one that is just sharing attention as opposed to offering knowledge. That has led to even proposing that pointing has a specific advantage, and specifically interrogative pointing has an advantage in retaining more information when infants are asked to get knowledge about what they've pointed to. Much less is known about social referencing as such behavior, and what I'm proposing along with others is that though social referencing has been most often and classically studied in uncertainty that is emotional, such as crossing the visual cliff or meeting a stranger or hearing a dog bark, those are actual experimental stimuli used in these studies, a self-propelling dinosaur toy moving towards the infant. That kind of uncertainty has elicited social referencing, which is literally generating a look at a social partner present in the room to get their input. What the argument is that epistemic uncertainty may be also conducive to social referencing in the same kind of social input seeking with the same kind of goal. So the epistemic uncertainty, again, what we mean by that, it's really seeking information, not seeking social engagement. So not knowing where things are hidden, needing information about location or a referent, or being surprised by things appearing or disappearing, or even by humorous events, maybe even like in Moritz study where things, spoon is put towards the ear. Few studies have looked at these things, but we still don't know if social referencing is actually in that kind of repertoire of communicative cues. So what we've asked in study 1 is very simple: whether infants at the age when they are known to engage in social referencing and emotional uncertainty would also engage in social referencing when they are facing epistemic uncertainty. And here epistemic uncertainty was the violation of expectation event, specifically violating the expectation that a parent, a primary caregiver of the child, would provide truthful labels. So here we ask the caregiver to mislabel familiar reference, familiar objects. This study was motivated by several key findings. I'm not going to focus too much on them, but I will mention that we know that as young as 9 months, infants do encode this kind of mismatch between referent and object, and that was shown through ERP signals. In core knowledge violation of expectation events, we know that infants look longer at those events. In semantic violation of expectation events, such as calling a duck a shoe, for example, infants do look longer as well. As I just mentioned, social referencing in emotional uncertainty and also in humorous situations is a robust behavior as young as 10 months, and even younger, but 10 months for sure. Here's our setup for this particular study. We have 3 conditions. Incongruent one, where the caregiver mislabels a familiar object. In this case, for example, instead of calling a cat, they would call it something else. So, look, there's a shoe. Look, there's a ball. A congruent label, here they would say, look, there's a cat, and no label condition, where they would say, look at this. So, crucially, this is the primary caregiver of the child. They're both facing a screen, and the events appearing on the screen first occluded, and then occluder is removed. And that's when the parent says their respective utterance. They know what to say because they have an earphone that gives them the phrase. This is between subject. So once the caregiver uttered their phrase, we are coding infants' explicit behavior, such as their social referencing towards the caregiver, and they have 10 seconds to generate these kinds of social looks. And what we did find is that incongruent condition elicited high proportion of social referencing as compared to congruent and no label condition. That was not evident in other measures of social looking, such as onset, how quickly they generate the first look, and duration, how long they actually look at the parent, allowing us to cautiously conclude, well, the data shows that social looks, but not the looking time at the source of the violation of expectation, which is the caregiver in this case, because they are providing their own information, indexes the actual avert response. Really briefly, I'll also mention that we've collected the data on physiological arousal of these infants as they viewed their respective events, either congruent, incongruent, or no labeling events, through having them wear this wonderful wristband, which is a research developed for research specifically. You put that on infants' chubby legs, and this is still work in progress. I'll report one of the measures that we found is that the measure of non-specific skin conductance response, peak frequency specifically, which has been previously implicated with adults as an index of this kind of information seeking in surprising events. We found that the in incongruent condition, infants' rate of increase in this particular measure was actually it increased, and then in congruent and no label it did not. However, that was not related to any of the measures of the social looks. That's up for debate, what that all means. It seems like these are independent processes. What happens implicitly, what happens physiologically, autonomic arousal response to violation of expectation events, and the avert behavior of infants, at least in our study, was not correlated. So from this first study, we conclude that 11-month-olds would exhibit the epistemic vigilance mechanism, which is triggered by their violation of expectation, hearing false label by a reliable informant. So as young as 11-month-olds, they would recognize that something is not right, and they would use social referencing to communicate with the social partner, as opposed to looking longer at the source of the violation of expectation, the informant in this case. They actively seeking input. That's what social referencing is. We don't know what kind of input they're seeking. Maybe they want some clarifications or disambiguations. To help us clarify or put infants in a very different scenario, but still consistent with the idea that social referencing is information seeking before being able to use other cues to seek information, we've placed infants that are 12 months in a situation when they are facing, so we're switching from violation of expectation to a referential uncertainty. And we wanted to see if they would use social referencing to seek information from an adult. And I'll explain the study in a moment. What do we mean by referential uncertainty? Well, imagine you're facing these two objects you've never seen before, and you asked, which one is a blicket? You've never heard the word blicket, which I know is hard to tell. It's an impossible question. There's no answer to it. There was no prior cues that would have led to there's no memory involved here. Completely impossible question. In this situation, if you can obtain information from somebody else, you probably would. We wanted to see if infants would as well. So really briefly about the background again, we do know that infants do form these situational epistemic profiles of social partners early on in the first year. And we do know that they've used social referencing when core knowledge expectations were violated, at least in two studies, sorry. And when infants in previous studies were presented with 2 novel labels and only 1 novel label when they didn't know which one to refer to, they also generated more looks and longer looks at the experimenter. So this literally a few studies, this another wonderful study by Louise Goupil et al. That showed that social looks were specific bids for help when information about where objects are hidden could be obtained from the caregiver. So these are the only studies that looked at social referencing as information seeking in non-emotional epistemic uncertainty. Here's our setup though. Here's the infant positioned right across from their caregiver. Infant is across caregiver. And then infant is introduced to 2 unfamiliar experimenters. One experimenter, the one on the left, is, in this particular case, playing the role of an informant. The other experimenter is playing the role of a non-informant. And what we mean by that, the experimenter that's informative is knowledgeable about object labels. So when the caregiver places an object on the table in a familiarization phase, the informant readily labels it, look, this is a book, for example. The informative person is equally engaging, equally socially ostensive, using child-directed speech, looking at the child and as much as the informant. The only difference between them is that the non-informant says, "Oh, is it? I didn't know that." And we have a set of utterances that they exchange as the object is presented on the table. No, I don't have the audio on this video, so I won't play this particular trial. The infant is presented with 4 familiarization trials during which we expected and found that infants did encode who's who. So informant and non-informant had an opportunity to present their case. What came after the familiarization is crucial, is a test phase, test trials, which presented the infant with that referential uncertainty. And that, oh, I have audio. All right. This is just one trial about a familiar object. There were trials with non-familiar objects, which were labeled as a DAX or... Now, this is the test trial. The caregiver asks the question, which one is the toma on 2 objects that the infant hasn't seen before and they have not been labeled before. And no one is speaking. There's 15 seconds of complete silence. Everyone, including the caregiver, is looking at the child readily, and the child has an opportunity to seek information. This is how we conceptualize this moment. This is a referential uncertainty moment when no information is available and the objects are out of reach. So as you might have expected, we coded infants' looks at the experimenters in this case. And in such high uncertainty situation, we found that informant was the one who elicited more looks. More first looks, more overall looks, and also longer durations of visual fixations, which this head-mounted eye tracker gave us. So at test, but not at other phases of the procedure, when the referential uncertainty was not present, infants referenced the informant more. So at familiarization, it was a chance. At test, it was more, and that was the case across our 3 measures. So from this study, we conclude that by 12 months, infants selectively seek information from knowledgeable people, and they use social referencing as a communicative means to seek epistemic rather than non-emotional information. And as such, they actively participate in a cultural interpersonal process of knowledge transmission. They actively solicit information from knowledgeable others. So overall, these 2 studies help us think more about how the interrogative or information-seeking communicative development unfolds, and that children are far from being passive recipients of top-down information from pedagogical others. They actively solicit it and specifically do so when they are in need of information, but not broadly speaking. That's the end of my talk, and I'd like to acknowledge the Lancaster University Baby Lab and everyone there who helped me with this. Thank you. We have time for some questions.
Hi, is this on? Can you hear me? No? Yes? Okay, great. Really, really amazing work, so interesting. I'm wondering for the last experiment, if you have some way of knowing whether or not it's specifically the uncertain condition where the informant is eliciting more looks, or if being informative has the infant look more to that individual, sort of regardless of the uncertainty of the circumstance.
Yeah, we do. So, but I kind of skipped over that a bit at the end in service of time. So the first thing is that familiarization phase, when the infant had an opportunity to either look at informant or non-informant was also coded for looks, and this is where we see chance levels of looking at one over the other. We also had just one trial, which was the warm-up training, when infants were presented in the same situation as the later test trials, but in this case they were presented with two objects that they knew labels for, and though it's just one trial, there was no preferential looking at the informant at that trial either. And then thirdly, reviewer 2 asked us to do some additional exploratory coding, and we did, which was great because once the objects are in infants' hands, so at first they are outside of their reach, but then later on they get the toys to play until the next trial starts. We also coded where the infant was more preferentially communicative to one or the other, so whether they given the objects more to them or maybe threw the objects or looked at them more. We've coded all of that, and we didn't find any preference for the informant overall, just at those strategic moments when it was uncertain. So we feel pretty confident it's the case. Any other questions?
Hi, I just have a quick question about how you're conceptualizing epistemic uncertainty. You contrasted it with the emotionally laden uncertainty in the original, the visual cliff paradigm. It's unclear what children are looking for in that study. It looks steep, it looks risky, I don't know whether I should cross or not. It can be conceptualized as epistemic uncertainty. It's just that the information could be conveyed with emotion. You can just smile to indicate, hey, it's okay to cross, it's not that deep. Or it could be something else. I'm just thinking about whether the contrast you think is real or what you think epistemic uncertainty actually is.
It's a fair concern, I guess, and I haven't quite thought about that. And the reason for that is most of the studies of social referencing in visual cliff paradigm, for example, they always code the information that was received to the infant as an emotional bid, positive, negative, exclamation, verbal, nonverbal, things like that. So it's never been that infants would receive an information that's non-emotional. So it could be that all these previous studies, the decades of studies, just haven't conceptualized it right, and you are right in a way.
I just wanted to point out that if there's a label that a person's or a baby's looking for, then it can't be conveyed by smiling, but it could be emotionally laden uncertainty under this definition. If a person could say the label, and another person could smile.
In this study, you mean?
Right. It's just that there was no other way to convey the label other than saying it. You couldn't smile to label the object. So I just wanted to point out that there's an interesting question about what is epistemic uncertainty. So just wanted
It's more philosophical than on the surface, yeah. I think we should move on to Tony. We're gonna skip the Q&A session for your talk, unfortunately, in the interest of time, and we will go straight into the discussion. So everyone will have an opportunity to ask a question about Tony's study as well. So our discussant is Paul Harris. Could we get technical support switching back to HDMI?
While that's happening, let me just say thank you to the three presenters today, and also for getting me their talks way ahead of time. So I have no excuse really for not offering integrative comments. I've had plenty of time to mull them over, which is not always the case for a discussant, which I'm sure you know.
Is it switched already? Is it switched already? work now. Do you want to do it freely with your slides, or
I could get started while we're trying to work out what's going wrong.
okay?
It will come. Okay, thanks so much. Okay. So it's afternoon of improvisation, but we'll go ahead. So just to remind you, I'll go through the three studies in order. So Moritz presented infants with those 4 different sequences. And if you remember from the photographs, the sequences either ended in the unexpected or unexpected. The 2 experiments were rather similar, except that one included neural entrainment and one did not. But the actual results were very similar. So in both of those experiments, infants displayed greater theta activation when they were processing the unexpected outcome as compared to the expected outcome. So one plausible interpretation then is that theta activation can be taken as an index of the processing of unexpected information. Moritz nicely integrated that with a broader story of the predictive capacities of infants. I have 3 questions about the paper. One was already raised by a questioner earlier, namely to what extent were the results stable across those 4 different types of variation, but that's something that clearly needs more data and can be explored easily in the future. But another, in some sense, simpler question that occurred to me was that in each case, Moritz and colleagues relied on expectations that the child or the infant will have built up in the course of the first year of life, expectations about solidity, number, and so forth. Whereas we know from a vast number of infancy studies that infants can build up expectations very, very rapidly. So if we go back to... I'll just try and keep talking here.
Yes, please.
If we go back to some of the classic studies back in the 60s, and I'm thinking of Robert Fant's papers that I remember by Zeman, Ames, and Moffat, essentially the same stimulus was presented repeatedly, babies habituated, and then you presented a novel stimulus. And these studies were instrumental in getting us going in thinking about the kinds of discriminations that babies could make. But the point being that those expectations will build up within several seconds or a minute or so within the context of the experiment. So an interesting question is whether that theta effect would also extend to those recently acquired expectations, or whether it's mostly generated in the context of long-standing expectations. The third question I have is perhaps the broadest, and it seems to me you could look at this theta activation as primarily a backward-looking reaction to an unexpected outcome, and I think that's the emphasis that Moritz is putting on his findings. But in principle, you could also think of it as a forward-looking receptivity to further input from a hitherto informative source. Now, in the context of these studies, those are confounded because the unexpected outcome is probably one that you would look at for further information. But there are experiments, I think, which dissociate those 2 possibilities. So, for example, I'm thinking of a study that I particularly enjoyed reading, which was by Katerina Begas, Theo Gliga, and Vicky Southgate, published in PNAS. And as it happens, they also looked at theta activation. But what they did was to, first of all, introduce the infants who were 11 months of age to 2 speakers, one of whom the infant discovered to be a native speaker of their language, and another informant whom the infant discovered to be a speaker of another language that the infant didn't recognize. And then in the test phase, the infant would be facing one of these 2 speakers, and the speaker would have in front of her a novel object. And the basic finding was that theta activation was greater when the infant was watching a potential informant whom they knew to be a speaker of their language. Now, in this case, it's hard to argue that theta activation is being driven by anything unexpected. The theta activation is probably being driven by the forward-looking expectation of getting some interesting information from somebody who's going to tell you something that you can understand. So that's a question, I think, which is worth exploring, the extent to which what we see in the Begas et al. Paper is parallel to what we're seeing in the findings that Moritz has reported. So turning to Marina's paper, study 1, 11-month-olds were more likely to look at a parent when the parent mislabeled a familiar object as opposed to labeling it correctly or not labeling it at all. And in study 2, the caregiver asked 12-month-olds to identify a novel object, and infants could seek information from one of 2 nearby informants, one who'd proven knowledgeable, naming familiar objects, one who'd proven ignorant, did speak and interact, but didn't provide any information. And the basic finding was that most of the infants' first and indeed subsequent looks were directed at the knowledgeable informant. So how should we interpret this type of social referencing in both of those experiments? So as it happens, the first experiment, where the infant was confronted by unexpected labeling, of course, would fit in with the broad interpretation that Moritz offered for his data, namely that that social referencing is a bit like theta activation in the sense that it's a reaction to the unexpected. But when we turn to experiment 2, we see a different pattern in the sense that the social referencing seems to be directed at a potentially informative speaker rather than being triggered by anything unexpected. So again, I think we find the same dilemma and the same interesting questions in Marina's paper as we have about the first presentation by Moritz. So just to try to, in the longer term, I think, integrate those findings, I think we want to know what the relationship is between theta activation and social referencing. And more broadly, we want to know whether these reactions can be construed as backward-looking primarily, forward-looking primarily, or some mix of the two. Okay, finally, let me turn to Tona's paper, and congratulations to her for surviving the technical travails. So just to remind you, 3 to 5-year-olds were told at the beginning which of 2 figures would make a music box play when that figure was placed on top of the music box. Half were given true information, half were given false information. Surprisingly, very few children left alone with these figures tried them out. And this is an intriguing non-result, but I think it's a positive result because Samuel Ronfard has obtained very similar findings when children are not just given a piece of information, but a piece of unexpected information. So very briefly, he showed children 5 Russian dolls, ranging in size, and he asked which they thought was the heaviest, and 99% pointed to the biggest. And he said, well, actually, the smallest one is the heaviest. Left the room and waited with the camera rolling for the children to check out whether he was right or wrong. Very few of them ever did anything. The vast majority of 3 and 4 or 5-year-olds didn't do anything except touch both or all 5 figures equally without any kind of dedicated investigation. It was only around 5 to 7 years of age, that children engaged in targeted investigation of the biggest and smallest, as if trying to determine whether the informant had been correct. So I think this lack of investigation is a datum that we need to pay attention to. But moving forward with the remainder of the experiment, when another adult came in and prompted the children to explore, most of them did indeed follow up appropriately on what the first informant had told them. They picked up the figure that the first informant had indicated. And of course, at this point, half of the children discovered that this figure was effective, the music box played. Half of the children discovered that it was ineffective. And when further questioned, most children now have a dilemma. When further questioned about what actually makes which figure is effective, the children can effectively go with what they were first told or go with the empirical evidence. And what Tona found was that the vast majority go with the empirical evidence. In study 2, as she just explained, she asked about an identical figure, whether that would have a similar effect. And I would like to be able to show you the data from that study, because I just want to underline the fact that although indeed children were impacted by what they had discovered, it was only about half of them who were impacted. In other words, children who had been given false information had discovered that the designated figure was ineffective. When asked about an identical figure as to whether it would be effective, about half of them continue to say that it would be effective. So we're seeing a shift, but it's far from pervasive. Putting it another way, half of the children are sticking with the original testimony and trusting it. So to set these in these findings in a broader context, I think it's worth thinking back to the paper that we heard, those of you at the pre-conference, from Olivier Mascaro, essentially asking very similar overarching question. When children are given testimony or hear a claim and discover some empirical or are presented with some empirical information which conflicts with that claim, how do they fare? Tona is concluding that by and large children go with the empirical information. Olivier was actually arguing the reverse, that by and large children stick with the testimony or the claim, notwithstanding contradictory empirical information. It would be nice if I could offer you a neat, clear resolution of this fairly severe conflict. I can't do that. It's possible that one of the factors that Tona mentioned, namely the order, is a key factor. But I think in both cases, it was true that the child was first presented with testimony, then with empirical information. And in the one set of studies, we see the child going with the testimony. In the other set of studies, we see the child going with the empirical information. More broadly, I think it's true that we, following a sort of long tradition in philosophy, are probably inclined to think that surely the child ought to be biased toward empirical information. And when faced with a conflict, to be inclined to abandon a claim in favor of empirical information. I actually think that's probably wrong, that the story of development, the story of the development of the relationship between these two sources is much more complicated. And just to, in some sense, make it a slightly stretched analogy, but I think a reasonable one, think about science, think about this conference, think about the fact that there are lots of empirical studies being presented, false belief, logic. But think about the fact that also there's a body of literature against which we appraise those individual observations, and exactly how to navigate between the more local empirical observations that we may have brought with us from our own laboratory and the larger picture that we're getting from colleagues is a delicate problem. And indeed, some of the most interesting papers at this meeting have been trying to navigate that very tension. So I don't think it's very surprising that we're seeing an equally problematic and difficult conflict engaging children's minds between the ages of 3 and 5. We struggle with it as relatively mature scientists. Let me stop there.